It's not appropriate. All right, so let me remind you of something. You know, we've been taking the inverse. Now, at the door, I wasn't asking you the inverse. I was just asking you what the sine, cosine, and tangent are. But if I did ask you, what is the cosine inverse of the square root of 2 over 2? What's the cosine inverse of the square root of 2 over 2? Pi fourths. Cosine inverse of the square root of 2 over 2 is pi fourths. Anytime you take the inverse, it's giving you an angle, right? Because you always take the sine, cosine, or tangent of an angle. The inverse gives you the ratio back. So I'm going to write something up here at the top that we talked about when we first started doing the inverses, is that the sine inverse of the sine of 7 pi 6. So I want you to think about this. Remember, I asked you what's the sine of 7 pi 6? What is that? What's the sine of 7 pi 6? 1/2. Is it positive or negative? Negative. So it's negative 1/2, right? So the sine of 7 pi 6 is negative 1/2. But the sine inverse of negative 1/2 is not 7 pi 6, right? So this, if I do it as a composition, it does not equal 7 pi 6. And we'll talk about why here in just a second. Remember, you are, what? Go ahead. It only goes to pi halves. You can only go from negative pi halves to pi halves. Does that make sense? When I take the sine, cosine, and tangent, I can take it of any and of the infinite amount of angles. But when we go the opposite way and take the inverse, you are limited to angles that go from negative pi halves to pi halves. Okay? Does that make sense to you? They can have the same value, but that is very, very restricted because of that graph. It wouldn't have been a function. All right, so remember for sine and tangent, so for sine inverse and tangent inverse, we are restricted to quadrants 1 and 2. And not only, 1 and 2, 1 and 4. Not only are restricted, but we have to call them from negative pi halves to pi halves. Even though the angle 11 pi 6 lives down here, we would have to call it negative pi 6. Remember that? Okay, so it's this part right here that's sine and tangent. For cosine inverse, remember we are restricted to quadrants 1 and 2. And that can go from 0 to pi, and it's these two quadrants right here. So when you take the inverse and you're doing cosine, your answers are always positive. You don't talk about negative angles. But with sine and tangent, you do get negative angles. Okay? Everybody okay with all that? Now, we know that we take the inverse, we switch x and y, all those beautiful things happen, but we also have an inverse, and it says recall, right? So we have some recall information here, that if I have f of the f inverse of x, it equals blank. So let's say I take, 2 times 3 is 6, and then 6 divided by 3 is 2. So I'm back where I started from, right? So if I take the function of the function inverse, it should spit x back out, right? And if I take the function inverse of the function of x, then that should also equal x. However, look at what I wrote up here. Isn't this the function inverse of the function of x? And I said it doesn't equal x. That's because there's some words up here. It says, given function f and its inverse, f inverse, if x is in the domain of both functions, then. So you see how sine of 7 pi 6 is not in the domain of both functions. Okay? It doesn't work that way. Because we can only go from negative pi halves to pi halves. Make sense? Yes, exactly. So it'll work for some of them. It doesn't work for all of them. Okay? You with me on that? All right. So let's look at this. This says, the properties of compositions of trigonometric functions are summarized below. All right. So if you see how we have sine of the sine inverse of x equals x, and the sine inverse of the sine of x equals x? So in one of these situations, x represents an angle, and in the other one, x represents the ratio, okay? So I want you to think about, in this group or this group, whether x would represent an angle or the ratio of two sides. So on the first one, in this first group, is x going to represent an angle or a ratio? A ratio, because you always take the inverse of a ratio for it to give you an angle, right? And then when you just straight up take sine, cosine, or tangent, you're doing that of an angle. Does that make sense to you? Okay, so when you take the inverse, okay, there's some things that you don't get to take the sine inverse of. What can I not take the sine inverse of? What? Well, okay, but if I'm going to take the sine inverse of a ratio, it's not going to have any pi's in it. It can, but that's not where your brain is. But what gives you the error on the calculator when you're trying to do sine inverse? Anything more I don't want you to actually try it on the calculator. Anything what? More than one, right? Sine and cosine, you can't take the inverse. You're never going to get, if you take the sine or cosine of an angle, you're never going to get anything more than one because the hypotenuse is always the denominator, right? So you can't take the inverse of anything greater than 1 or anything less than negative 1. Does that make sense? So since here x represents that ratio, that means x has to be between 1 and negative 1. That's the only thing that works. And negative 1 and 1 are fine, but it can't be 1.1 or anything like that. Same thing goes for cosine. Is tangent restricted the same way? Think about this, and think about these graphs we did with sine and cosine. Do you see how the sine and cosine graphs, the max is 1 and the min is negative 1, right? What are the max and the min of a tangent graph? They don't have one, right? So it's negative infinity to infinity. Now, when you take the sine of an angle, of course, we can take the sine of any angle, but in order for us to take the sine inverse and get this back out, right, the only thing it's going to spit out to me is anything that goes from negative pi halves to pi halves, and we do get to include them. And 0 to pi for cosine. And then for tangent, think about your tangent inverse graph. Do you remember when we did the inverse and we graphed the inverse? And what was your max and min then? What happened to those asymptotes? They went from vertical to horizontal, right? And so where were those? At what? Do you remember? Pi halves and negative pi halves, right? So it was negative pi halves to pi halves. Do we include this or not? No, because they were asymptotes there, right? You could have just what now? Pretty much, yeah. Exactly. So here's the thing with this, okay? These little rules, these aren't like 1,000 rules you have to remember. The only reason you really care about the rule itself is if it's something you don't get to calculate. Or even if you do know what it is, it just makes it easier. But for instance, look at number 1. You want the sine of the sine inverse of negative 1/3. So first of all, is the negative 1/3, does it represent a ratio or an angle? Ratio. If you're taking the inverse here, this is a ratio. Means I have a ratio here and I'll have a ratio in the end. Do you know what the sine inverse of negative 1/3 is? No, neither do I, okay? So it's not something I can actually calculate and come up with an answer. But this negative 1/3, is it something I am capable of taking the inverse of, like on a calculator or something? Does it fall between negative 1 and 1? Yes. So since it does, I really don't care what the angle is. Since it does, this rule applies. And my answer is just negative 1/3. Okay? Because the sine of the sine inverse would be negative 1/3 if that number falls within these little ranges. Okay? So now let's look at number 2. I want the arc cosine of the cosine of pi fourths. So what does this represent, an angle or a ratio? An angle. And be careful just because you see a pi, because some of these will be ratios that have pi's and some will be angles that don't. But because I'm taking the cosine of it, this is an angle, right? And does that angle fall between negative pi halves and pi halves? Yes, it does. So that means my answer then, since cosine matches cosine here, is just pi fourths. If I wasn't sure, or if I didn't know the rule, here that's a problem. I wouldn't be able to do it. Here it's not a problem because what's the cosine of pi fourths? Square root of 2 over 2, right? And then what's the arc cosine of square root of 2 over 2? Pi fourths, right? Like you get it that way anyway. But when you can't do it, you kind of need this to follow. You with me on that? Okay. So if you get confused, but you can actually calculate it, just calculate it from the inside out. It's fine. So let's look at number 3. I want the arctangent of the tangent of negative pi halves. This represents a what? An angle. Okay? And so does that angle fall within the range of angles that I have? No. Because look, they're not included. Right? Or what's the tangent of negative pi halves? It's undefined, right? And so you can't take the arctangent of undefined. You can't do anything with undefined. So this answer here is just does not exist. You can't do it. D-N-E. Now number 4, there's a mistake there. That shouldn't say tangent inverse and tangent inverse. So we're going to mark out the first inverse there. And does this represent a ratio or an angle? A ratio. Does the ratio fit within the boundaries that we have for tangent inverse here? Look at this. Yes, it's negative infinity to infinity, right? Because it's a ratio, not an angle. And so negative infinity to infinity, yeah, because you don't know what the tangent inverse of negative 9 halves is, right? So your answer is negative 9 halves. So let's look at number 5. Arcsine of the sine of 3 pi fourths. This is an angle, right? Does 3 pi fourths fit within negative pi halves to pi halves? No, because that's in the second quadrant. So this does not mean that I can't get an answer. What this means is that this does not equal 3 pi fourths. Okay? It doesn't just spit out just like the rest of them do. Okay? So on this one, we have to actually work it from the inside out. So I'm going to find the arcsine of, so what is the sine of 3 pi fourths? Square root of 2 over 2. It's positive, right? So then what is the arcsine of the square root of 2 over 2? Pi fourths. So the answer to that one is pi fourths. It's not just a straight up, I get the answer from the inside part. Do you understand why? Because you have to see if it fits within the little range. Okay, cosine inverse of 2/5. This has to be a ratio. Does 2/5 fit between negative 1 and 1? Yes, so the cosine of the cosine inverse then is just 2/5. Everybody good? Now, you can see, here's this little thing. It says, always be sure to check if the coterminal angle is in the domain. Let's review what coterminal angles are. Remember when I said you have an angle that's like 11 pi sixths, right? So I can say this angle here, this is 11 pi sixths. Does that look about close, or at least we can assume? Okay, so a coterminal angle would be this, and it would be negative pi sixths. But there's an infinite amount of coterminal angles. I could keep going, and then this would also be negative 13 pi sixths, and so forth and so on, right? It's like us running around a track, and we all end up in the same spot, but we might have run a different number of laps, and we might have started going a different direction, okay? So coterminal angles are really, really easy to find like this, okay? We good? So let's look at number 7. I want the arcsine of the sine of 5 pi thirds. So does 5 pi thirds fit between negative pi halves and pi halves? No, it does not, okay? And this represents an angle, right? So what I can tell you here is that this does not equal 5 pi thirds because it doesn't fit in within that. But 5 pi thirds is in what quadrant? The fourth quadrant. So this is 5 pi thirds, but coming this way, what could I call it? Close. Negative pi thirds, right? It'd be the same as negative pi thirds. You with me? So then I know that I could have the arc sine of the sine of negative pi thirds. And does negative pi thirds fit between negative pi halves and pi halves? It does. And so that means my answer is negative pi thirds. Here's another option, because really the reason you have to have the rule is for when you get weird stuff that you don't know the answer to. But I could have found the sine of 5 pi thirds. The sine of 5 pi thirds is a negative square root of 3 over 2, right? And then the arc sine of negative square root of 3 over 2 would give me that negative pi thirds. It's another way to work through it. But you just have to use that rule when you can't calculate the stuff yourself. So let's look at number 8. Cosine inverse of the cosine of negative 4 pi thirds. So negative 4 pi thirds, does that fit between 0 and pi? No, it doesn't. Negative 4 pi thirds is in what quadrant? Third. Is it in third? Second, because since it's negative. Negative 4 pi thirds is going to go from here. This is 3 pi thirds. 4 pi thirds is like here somewhere. Okay. So instead of negative 4 pi thirds, since it's in the second quadrant, what's your second quadrant angle, your second quadrant pi thirds angle? 2 pi thirds. Okay, so we know then that the cosine inverse of the cosine of 2 pi thirds, that fits between the 0 and pi, right? Since that fits between the 0 and pi, I've got 2 pi thirds as my answer. Any questions about that? Ask me something if you get lost. Okay. Well, I think that probably the best thing to do here, honestly, is that if you can find the tangent inverse of this, we can just work them that way. Like it fits within there and it makes it easier, but here I don't have to do it this way. Here I'm going to have to. So let's work these a little bit differently then. I mean, pi thirds fits within the little range that we care about, right? But even if we're not thinking about that, because really down the line, I'm not so sure that this is how your brain's going to work on it anyway. I feel like most of you are just going to work them anyway, which is there's nothing wrong with it as long as you can work them and you're not making stuff up, right? So as long as you know, but look at this. This is the tangent inverse of pi thirds. What does that pi thirds represent here? A ratio or an angle? When you take the inverse always has to be of a ratio. So this represents a ratio, but what does it look like it should be? An angle. But it's not an angle, even though it has a pi in it. You with me? So on this one, you really can't calculate it because you know what the tangent of pi thirds is, but you don't know what the tangent inverse of pi thirds is. You with me? But does pi thirds live within that negative infinity to infinity thing? It does. So since that works and these match, the answer is just pi thirds. See, that's the problem, is you can't just calculate this one. Those, when they don't look like, or they're not what you say anything you know the values of, you have to understand how they can cancel each other out. And then we'll kind of do 11 and 12 a different way, but let's look at 10. Cosine of 3 over 2, what does that represent? Angle. You always take the sine, cosine, or tangent of an angle. So this represents an angle. It doesn't have a pi stuck on it, but pi's calculated in it. It could be anything. Okay, but it's still an angle. It has to be if you're taking the sine, cosine, or tangent. Okay, it's not. That's it. It's three halves, right? So does 3 halves live within the angles that we would be able to take the cosine inverse of? Cosine goes from what to what? 0 to pi, right? So pi is 3.14159. 3 halves is 1.5. It's right about here somewhere. So does 1.5 live within that from 0 to pi? Yeah, 1.5 is less than 3.14159, right? So that means then that my answer is just 3 halves. The weird ones are the ones you have to be able to reason through. 11s, not so weird. Okay, now the problem with 11 is that pi doesn't live between negative pi halves and pi halves, but all that means is that your answer isn't pi. But nobody asked you what the answer isn't, they're asking you what the answer is, right? So what is the, so I'm going to take the arctangent, what is the tangent of pi? Zero. Tangent of pi is 0, so then I just want the arctangent of 0. So what angle that lives between negative pi halves and pi halves gives me a tangent value of 0? What angle gives me a tangent value of 0 that has to live here? 0. The zeros get confusing because they could be angles or ratios, and sometimes you get your mind a little messed up there. Okay, so now let's look at this one. Since this is something we can do, we don't even have to worry about whether or not it lives where it's supposed to live, right? So we do sine inverse of, well, what is the sine of negative 11 pi 6? So first of all, what quadrant is that? First, because it's negative. So I really just want the sine of pi 6. What's that? 1/2, right? And then what is the sine inverse of 1/2? Pi 6, and that's your answer. You're going to like the back better than you like the front, because when they don't match, you're not going to get, if you get that weird stuff, there's another way to do it, and I think you'll feel a little bit more comfortable. Any questions at this point? Okay, so on the back, when it's not tangent and tangent inverse and sine inverse, they're mixed, okay? Which actually makes it easier, because those rules are all out the window. You don't get to just cancel anything out. You just have to work inside out every time. So I want the cosine inverse of the sine of pi 6. So that means I want the cosine inverse of, well, what is the sine of pi 6? 1/2. And then what is the cosine inverse of 1/2? Pi thirds. And that's your answer. You see how that works? You basically have to go forwards and backwards on each one of them. Anybody have a question? All right, arctangent of the cosine of 0. So arctangent, what's the cosine of 0? 1. Okay. Then the arctangent of 1, what angle gives me a tangent value of 1? Pi 4. It's okay. It takes like a little, couple of little like steps in your head. That's okay. So then sine inverse of, so what's the tangent of negative pi 4? -1, right? So -1, and then the sine inverse of -1, negative pi halves. Everybody good with that? See how this is working? All right, so then I want the arcsine of, what is the cosine of 5 pi 6? Okay, so it's square root of 3 over 2, and then 5 pi 6 is in the second quadrant, so it is negative, right? And then arcsine of negative square root of 3 over 2. So remember, you can still use the hand trick. If I want sine to be square root of 3 over 2, that's what this is. So it's pi thirds, but since it's negative square root of 3 over 2, it has to be negative pi thirds. Okay, everybody good with that? All right, so then cosine inverse of the tangent of pi fourths. So I want the cosine inverse of, so what's the tangent of pi fourths? 1. And then the cosine inverse of 1 is 0. Good. And this shouldn't be arctangent to the -1. That doesn't make any sense. So arctangent, what is the sine of negative pi halves? -1. It's -1. All right. And then arctangent, I left off my seat. Arctangent of -1. So the angle that gives me a tangent value negative pi fourths. Good. When you're doing the compositions, if you're starting with an angle, you're ending with an angle. So that kind of keeps you, because it is easy to write the wrong thing down. I mean, I see where your mind's going there. So I want the cosine of the sine inverse. So the sine inverse of 1/2 is what? Pi sixths. And then the cosine of pi sixths is square root of 3 over 2. Sine of the arctangent of 1. So what's the tangent inverse of 1? Pi fourths. Good. And then the sine of pi fourths is square root of 2 over 2. Good. And see how much better, how much quicker that's coming into your minds now? Right? It was such a struggle for a while. Y'all are doing good. All right. So the sine of the arc cosine. So what's the arc cosine of 0? What angle gives me a cosine value of 0? Pi halves. What angle gives me a cosine value of 0? The angle would be pi halves because your x value is 0. Does that make sense? You understand why it's that? Can I stop it? Oh, would you? Oh, Eddie, grow up. What's the sine of pi halves? 1. You got time for that. You got to learn this. So cosine of the tangent inverse of the square root of 3. So what's the tangent inverse of the square root of 3? Pi thirds. Good. And then cosine of pi thirds is 1/2. Good. But pay attention when you are doing these, when they match, whether it's an angle or a ratio, so you don't fall into a trap. Okay? All right. Now, let's look at what happens when they're mixed and we don't know what, like I don't know what the cosine inverse of 8 over 17 is. Neither do you. It's all fine. So it says you let the inside equal theta, determine which quadrant it must lie in, draw a right triangle to find the missing side. Okay, so if I have the cosine inverse of 8 over 17 and the cosine is positive, what quadrant am I in? First. Okay, so cosine is positive in the first and fourth, but when I'm taking the inverse, I'm only restricted to first and second, so it has to be the first. Okay, so my cosine is adjacent over hypotenuse, so 8 over 17. This is my theta, right? So then I have to find this y value. How am I going to do that? Pythagorean Theorem, because we don't have a calculator to do the trig. So 8 squared plus y squared equals 17 squared. What's 17 squared? Well, 289. You need to know your perfect squares up to 25, because otherwise this is really gonna, I've been telling y'all that. Well, you're not going to be able to get this stuff done. This is 64. So what's 289 minus 64? Stop cheating on your calculator. 225. So what is y? 15. Pythagorean theorem cannot take you this long. You have to know these things, and you got to be able to fly through it. That is a 7th grade skill. All right, so then when I want the tangent of theta, tangent is opposite over adjacent, so that is 15 over 8, and you're done. Easy enough? Okay. I did, yes, I did. That's why, yeah. All right, so number 24. Well, they're actually in the Quizlet thing that you were supposed to join forever ago, because I've been saying this since school started. All right, so sine of the arctangent of negative 12 over 5. So if tangent is negative, what quadrant am I in? 4th. Okay, so I'm in the 4th quadrant. Tangent is opposite over adjacent, so this is 12 over 5, and this one has to be negative because we're in the 4th quadrant. So Pythagorean theorem is going to give me 5 squared plus negative 12 squared equals r squared. So 25 plus, what's 12 squared? 144. What's 25 and 144? 169, so what's r? 13. So then I want to find the sine. So the sine of theta is equal to the opposite, which is negative 12, over the hypotenuse, which is 13. And you're done. Okay. All right, questions? We good? This again, just like everything else, you practice it a little bit, you'll know it. You don't have to practice it like, you know, hours and hours a day, but you got to do it. You got to do your homework and think through it so that it clicks with you a little easier, okay? Questions? All right, good deal. Go ahead and get that put in your ISN.